My name is Silas Nichols. I am the Principal Geotechnical Engineer with the Federal Highway Administration. And I have a simple question. I actually have a lot of questions throughout this talk, but I'll start with the simple one that is the title of the presentation. Could we have known? If we had access to bigger data sets of better data that allowed us to better predict or put prediction models together, could we reduce the frequency of failures that are very common to geotechnical engineering? Could we prevent catastrophic failure? If we had access to bigger sets of better data, the right data, could we start to address common geotechnical problems in a better way that we have, such as deterioration of steel in varied applications? Could we handle complex soil structure interaction problems, such as scour? Could we do that a little bit better? I ask, are we as a discipline somewhat negligent in how we think about data and its benefits? And I don't use negligent in a legal sense. I use negligence in sort of a way of thinking of it as sloppiness or carelessness and how we think about the relationship of data to broad problem solving. To answer this, I'm going to go back about a year. I was coming out of a meeting in Boston, Massachusetts. I was getting on an airplane to go to Washington, D.C. I was horrifyingly tired. I didn't feel like doing any real work on the airplane, so I grabbed a copy of The Economist and I started reading through an article entitled "Shining Light on Latin America's Homicide Epidemic." Yeah, murders in Latin America. I realized very quickly that I was, in fact, doing work. I wasn't just reading an article. The article, in summary, really talked about how rich and poor countries around the world use data, and specifically geospatial data, to help them out in policing and crime prevention. In Latin America, it's estimated that 80% of all the homicides that occur in large and medium-sized cities occur on 2% of its streets. And so, obviously, in this case, better use of data, better analysis of big data sets would help you in understanding how to deploy resources, how to more beneficially attack a problem such as crime prevention or policing. The article went on to cite a report done by the Inter-American Disciplinary Bank that was published in 2012. A criminologist named Lawrence Sherman concluded in that report the thing that really sort of changed the way that I think about data. What he concluded was that Latin American countries really just don't have access to the kind of data to do this work. The problem is that when they report crimes in Latin America, you might get what the crime is. It might be a knifing or a gunshot, something like that. It may include the town that it actually occurred in, but it doesn't include enough data for them to actually do analysis on how to deploy resources. He concluded that this chronic lack of data is not an obstacle to solving important problems. It is the most important problem. I'll say that again. The chronic lack of data is the most important problem. So, I turn now to our discipline, geotechnical engineering. We collect a significant amount of data. We collect data for the purposes of doing just about anything, research, project development, project design and construction. We don't really use data, though, in an effort to better understand how to solve bigger or broader problems. I recognize that we have some issues here, why this would be the case. In my opinion, and I'm in transportation, so I'll speak to my experiences, part of our problems are our tendency to cling to codes and minimum requirements for how we want to do work. A culture for sticking to traditions, doing things the way that we've always done them. And quite honestly, that leads us to a fear of change. And as a result, we don't really want to do things in a way that is what I see as transformative in how we actually evolve the discipline. We've long known that data is important. However, we've not had these sort of transformative thoughts on how to better use data for broad problem solving. As a result, we're somewhat stagnant in dealing with some of our most consistent and our most important problems in the discipline. So What we really need here is good, big picture ideas. We need them now. We need ways to sort of think about some of these bigger, broader problems I'm going to talk about in just a moment. And so before I get there, I'll ask 3 more questions. 1, how do we come up with good ideas? And does this discipline have good ideas? That's 1 question. 2, how do we distinguish a good idea from a not so good or a bad idea? And then 3, how do we put good ideas to work? How do we actually implement a good idea? There's a lot of research out there that talks to how good ideas come about, how people come to the idea of a good solution for a complex problem. I'll point to Dr. Marr's presentation on Sunday. One of those ways is through good judgment. And it's good judgment based on the empirical evidence that you have at any moment in time. It is your gut reacting to what the best information is at the time that you actually have it. The second way that we think about coming up with good ideas is through careful analysis of facts and theory, right? The more rigorous approach of coming up with an idea. The diversion into this good idea thing got me to thinking about whether or not we really do have good ideas about how to deal with our data problem. And I think we do. I think we do have a really good idea coming on board right now. Many people in this room are familiar with the concept of DIGS. It is a data transfer protocol that will eventually really sort of transform the way that we think about communication of geotechnical data. Agencies like mine, Federal Highway, State Departments of Transportation, other agencies around this country and around the world are quickly working to make much larger data sets available for use by designers, by constructors, by researchers for the purposes of project development, project delivery, and research. Big data analysis will also allow us to address gaps in the discipline that I think and I believe simply just require more data for solutions. So, what is it that we're after? What is it that we don't know about this data problem? Even though we all, and I, understand the importance of data, I do believe that these are 2 really, really difficult problems to answer. And it's critical that we're able to answer them in order to move forward with implementing what I think is a good idea. I'll say that a different way. DIGS is going to be successful. DIGS will be successful very quickly in helping us better communicate geotechnical data. However, the idea of a transformative advance in the discipline really requires much more care and thought on how we're going to deal with data to handle some of our geotechnical applications that will require a lot of things. Among those, the availability of data, not information, data. The idea here is that data is the stuff that actually comes out of a test result. Information is the scan of a PDF. The scan of a PDF does nothing for us. The data that actually is generated as part of the test is very meaningful to us with respect to communication and processing and analysis and problem solving. Consistency and standardization of that data. We all need to be talking the same language. Protocols for data storage. How will we actually archive it so that we can effectively communicate it? My transportation partners, the FHWA, are currently working on all 3 of those topics right now. But there are other requirements. Processing of data, transformation and management of data. Those are the extra pieces that we have to deal with, and those are the pieces that are going to help us get to a position where we can make transformative advances in how we actually solve our bigger problems. So, we know that data is crucial to solving problems, but we as a discipline don't address the lack of data as a truly crucial problem. This is real. Case histories point to this with regularity. Load-test databases suffer not only from a lack of data, but from an abundance of erratic or highly variable data. We obsess over risk and uncertainty all of the time, even though we all know at our heart that it is rooted in a lack of data. The curation of the right kinds of data allow for vast processing on a systems level, not an element level. We as a group have to stop thinking about data as a problem at a project level and start thinking about leaps in knowledge that allow us to address our problems in the aggregate. Big data is transforming entire sectors of our economy around the world. Crime prevention and policing was the example I used at the beginning. I think geotechnical engineering could be one of those disciplines that is actually affected by better use of big data and analysis of big data. We can certainly do this. And there are a bunch of different things that I think we can sort of think about where we could be better if we had better access or curation of the right types of data. So think about some of these problems. Settlement prediction. We're currently working on calibrations at the service limit state. We're looking at settlement as a load component and how it actually works with respect to bridge and service life of bridges. Materials as science. Looking at soils as not cohesive or cohesionless, but in much more broader ways with respect to behavior. Large deformation analysis or debris flow. Scour analysis. We do not treat scour as a complex geotechnical problem. It is. Replicating field behavior in the laboratory. Extreme event prediction. Probabilistic design approaches. Liquefaction triggering, performance management, asset management. All of these, in my opinion, are data-driven problems that can be solved by better access to bigger data sets. So, to close, I just want to go back and think about one of those problems I mentioned at the very beginning of this, the deterioration of buried steel. Presently, with regard to design for steel that we bury, I think we're satisfactory, right? We try to control the aggressiveness of the environment that we actually bury steel in, where we can do that. We always try to protect the steel before we bury it. Protection takes on many forms, either sacrificial steel or covering. We use a lot of galvanization, a lot of epoxy, other things to cover steel. But what if we understood corrosion in geotechnical applications a little bit better? What if analysis of bigger data sets allowed us to consider such things as metallurgy or the chemistry of the material as a factor in corrosion initiation, corrosion rate, or spatial variability? What if the analysis of different big data sets allowed us to consider whether or not our current approaches for characterizing aggressive environments were the most effective ways to do it? What if rigorous big data analysis allowed for a transformative advance in our understanding of corrosion and allowed us as a discipline to, for instance, assess the current state of a piece of buried steel, such that we can make decisions on that might allow us to prevent catastrophic failure due to corrosion? What if, maybe, just maybe, we could have known? Thanks.